Okay. Okay.
Applications and motion is plane. For example, the kinetic energy of a projectile at maximum height. What is the velocity of a projectile at maximum height here? U cos theta is the velocity of a projectile at maximum height. H maximum, the velocity is that much. Potential energy, PE and KE we want to find out and find the ratio of those two. Now here kinetic energy, KE is equal to half m v square. What is the velocity at maximum height? Half m u square cos square theta. Potential energy is equal to mg max. Mg into h max means u square sin square theta by 2g. These two cancel. Mu square sin square theta by 2. Now we want to find out the ratio between kinetic energy and the potential energy of a projectile at maximum height. Kinetic energy of mu square cos square theta by half mu square sin square theta. It is equal to cot square theta. This is the ratio between kinetic energy and the potential energy of a projectile at a maximum height. Cot square theta. Kinetic energy. Next, potential energy by kinetic energy means tan square theta. Tan square theta. Next application. The relation between maximum height and time of flight we want to know. The relation between maximum height and time of flight. What is the formula for maximum height? H maximum. Relation between T and H maximum we want to find out. H max is equal to u square sin square theta by 2g. T is equal to 2u sin theta by g. Here from this u, tg by 2 sin theta. It is equation 1 and equation 2. It is 3. From 3 and 1. H max I write it as h. U square means t square g square by 2 square sin square theta. We substitute u this value. Sin square theta by 2g. G cancel. Sin square theta cancel. It is 2. Square means 4. It becomes 4. How much you get? 1 by 8 gt square. H is equal to 1 by 8 gt square. This is the relation between time of flight and maximum height. Maximum height. Next one. Relation between maximum height and range. Relation between range and maximum height h. Maximum height h. Here we write range. Maximum height h. Range is equal to u square sin 2 theta by g. H by r, right? H by r. G cancel, u square cancel. H by r is equal to sin square theta by 2 sin theta cos theta. Square cancel. Here there is 2 also there. 1 by 4 tan theta. That means 4h is equal to r tan theta. 4h is equal to r tan theta. That is the relation between h and r, maximum height and range. maximum height and range. Next, relation between time of flight and range and angle of projection. Time of flight and range. Time of flight and range, here t and theta. We want to find out the relation between these three. Here t is equal to 2u sin theta by g. It is equation 1. Or u square sin square theta by sin 2 theta by g. This is t. Now we go square the equation 1 and divided by 2. T square by r we write 4u square sin square theta by g by u square sin 2 theta by g. U square cancel. 4 sin square theta by g cancel. 2 sin theta cos theta sin 2 theta. Sin square theta gone. It is 2 tan theta it becomes. That means t square is equal to 2r tan theta. T square is equal to 2r tan theta. Here g square also there. G. That means gt square. Gt square is equal to 2r tan theta. Here square of g square. Only one g cancel here. Here gt square is equal to 2r tan theta. Next. For a projectile, in case of complementary angles of projection, ranges are same. Ranges are same. For that, in the case of if h1, h2, r1 is equal to r2, in that case, theta 90 minus theta, already we see that in the previous class. Now, in case it is also we derive h1 plus h2 is equal to u square by 2g. It is also derived in previous class. Now we write r1 is equal to r is equal to, we write h1 is to h2 is equal, h1 into h2 is equal to how much? From this we find the relation between range and h1 h2. Here u square sin square theta by 2g. Here u square sin square 90 minus theta by 2g. U to the power of 4 sin to the power of 4 sin square theta cos square theta, it is become cos square theta by 4g square. 4g square. Now I multiplied 4 and divided by 4 g square sin square theta u square sin square theta cos square theta. We simplify this one. It becomes 16 here. It becomes u square, u to the power of 4 it actually. U square sin 2 theta whole square. U sin 2 theta whole square by g. This comes under that means it is a range by 16. R is equal to 16 square inch. Square is equal to 16 h1 h2. It is 4 root h1 h2 is equal to range. This is the relation between range h1 h2. Next one, the product of times is equal to how much? The relation between time of flights and the relation between time of flights and range. We write it as T1 is equal to 2u sin theta by g. T2 is equal to 2u sin 90 minus theta by g. Time 90 minus theta by g. 2u 90 minus theta by g. And it becomes 2u cos theta by g. Now T1, T2, we write it as T1, T2, product of time of flights of the two bodies. Becomes 4u square sin theta cos theta by g square. Now we write it as 2 into 2 u square sin theta cos theta by g. It becomes range u square sin 2 theta by g into 2 by g into T1 T2. From this we write T1 T2 is equal to 2 by g or half g T1 T2 is equal to range. This is another relation between T1 T2 and range. Next relation. We know the equation for parabola. We know the equation for parabola. From this we write the equation in terms of range. Y is equal to x tan theta minus half gx square by 2u square cos square theta. If you simplify this one, x tan theta is common here. What you get? 1 minus x by r we get. This is another relation. If you common x tan theta, we get that relation. 1 minus x by r is the range. Next one. For example, we have the equation for the parabola. Y is equal to ax minus bx square. Capital letters or small letters maybe. Those are constants. A, B are constant. We know A is equal to tan theta. B is equal to g by 2u square cos square theta. Here, range is equal to A by B. Write it A by B, we get the formula for range. It is equation 1. Maximum height. A square by 4B. Write A square by 4B. We get the maximum height. Theta is equal to tan inverse A. From this relation, tan inverse A. It is second one, that is third relation. That is the third relation. For example, a body is projected like this, obliquely from the top of a tower. For example, a body is projected like this, like this. We get an angle theta here. With velocity u, it becomes u cos theta. It becomes u sin theta. Height of the tower I say h. Then the time taken by the body to reach the ground. It moves like this. The time taken by this body to reach the ground is given by the relation height of the tower formula use. Minus h is equal to minus u sin theta into ut plus half gt. So we use the height of the tower formula. In the place of u, put a u sin theta. U sin theta. Similarly, in this range, we want to find out the range. Time of flight, from this we can find the time of flight also. The time taken by it to reach the ground. Horizontal range we want to find out here. R is equal to u cos theta into t, time of flight. Here we substitute this time from this equation. From that we get the range of a projectile. By using these two equations, we get the unknown quantities in this problem.